An arithmetic sequence is a sequence in which each term goes up or down by the same amount. So either each time we're adding, say, 5, or maybe we're minusing 7, or maybe we're adding a half. That's okay too. But only those. We're not timesing, we're not dividing, we're not squaring, we're adding or subtracting, that's it. Okay? So, which is nice. So last lesson you were looking at lots of different types of sequences. This one, now we're looking at more specific. This is an arithmetic sequence. 5, 7, 10, 13, because what's it going up by each time? 3. Great. The next one is not an arithmetic sequence. Why not? Exactly. The first 3 look like they could be an arithmetic sequence, but then the next term ruins it. It goes up by 3 instead of 2. Is everyone okay? Beautiful. Now, the definition, we let, now UN, denote the nth term in a sequence. So that means U1 would be the first term. Does that make sense? U2 would be the second term, and so forth. Is that okay? In the sequence above, 4 was U1, 7 was U2, 10 was U3. Is everyone okay? Make sense? Good. So UN, it denotes the nth term, but UN also gives us the rule for the sequence. Remember how we looked at rules in terms of n, like 2n minus 1 and stuff like that? UN is essentially also the rule for it. If UN, now I've got it in brackets all of a sudden. Remember last lesson when we had things like that 2n minus 1? It denotes the arithmetic series generated by UN. So like, say that one there. Oops, back here. Okay, you'll understand it a bit more when we do examples. If UN is an arithmetic sequence, then D, which means the common difference, is UN plus 1 minus UN. That's just a fancy way of saying D equals any term minus the previous term. Just a fancy way of saying that. And it has to be just the one previous. So again, let's go back to that previous example. Is everyone okay? Let's go back here to this example that we said was an arithmetic sequence. How could I find D? And there's more than one way. What could I do to find the common difference for that sequence? You could do 10 minus 7. Or you could do 7 minus 3. Or you could do 13 minus 10. Either way, we're going to get 3, and that makes sense because we already said it's going up by 3, so that is the common difference. Is everyone okay? Okay, the general term formula, like I said, it's UN. So, for any arithmetic sequence with first term U1 and common difference D, the general term or the nth term is given by UN equals U1 plus n minus 1 times D, and I'm pretty sure that's on your information booklet, okay, which is cool. So you can use that formula to work out the rule that generates the sequence, and you can use it to find any particular term in that sequence, which is what we'll do in a second. So I show you now. So consider the sequence. There's a sequence of numbers. First of all, show that the sequence is arithmetic. Okay, maybe I'll make a note here, A. To do that, you need to show that it has a common difference. Let's write that down. Need to show that it has a common difference, which means at least more than once, I need to show that the difference stays the same. Is that okay? Can you help me with that? How could I show that? Yes?
3 plus 4 is 7.
Yes, what's the kind of...
7 minus
Yeah, exactly. So 7 minus 3 is? Can you show me that again? Exactly. You don't have to do it a third time, and you just need it at least twice. Therefore, what do we now know? What value do we now know? D. D equals 4. Therefore, it's arithmetic. That's the kind of setting out I want. Oops. Do you understand the logic? I've shown that there's a common difference. So I state D is 4, then I state it's arithmetic. Is everyone okay? Beautiful. B. So now I want a formula. I want that UN. What's the other thing I need to know to find the UN formula? We've got D. Look at the formula again on the previous page. What was that other thing? No, it'll be in terms of N actually. What's the other thing in there? U1. Exactly. What is U1 in this case? 3. Shh. U1 is 3. Now let's write down the formula for UN. UN is U1 plus N minus 1 times D. That's the formula. So can someone put what we can in there? What can we do? Times 4. If you put the 4 in front of the N minus 1, that's also okay. Is everyone okay? And now I'll just expand and simplify. Do you want to take a moment, expand the brackets and then simplify and tell me what the final rule is? I would like the N term first and then the constant. Yes, because you get 4n minus 4, but then the plus 3, 4n minus 1. Is everyone okay? Beautiful, I'll write that down. 4n minus 1. I want n to stay around. Like, my rule is in terms of n, so now I can use it to find any term I want. I can find the 100th term, I can find the 10th term, whatever I want. Is everyone okay? Cool. C. Find the 50th term. What do I do? For n. And you can write it as U50 equals 4 times 50 minus 1, which is beautiful, 199. Okay, now, is 87 a term in the sequence? You don't have to know how to do it, but look at the wording. Is 87 a term? What would we let 87 equal? Yes, UN, exactly. I want to know if UN can ever equal 87. Does that make sense? So we let UN equal 87, and then I put it into the formula. How would I put that into our formula, which is down here, UN equals 4n minus 1? Beautiful. Okay, so we're going to solve it. I add 1 to both sides. Cancel, cancel. 4n equals 88. Divide by 4, n is 22. Basically, girls, what kind of n? N is the position of the term. What kind of value of n can I not have that wouldn't make sense? Not a whole number? Does it need to be positive? Yes, because it's a position. So, positive integer. Basically, n has to be a positive integer. 87 is a term in the sequence. Full stop. That's it. So basically, if you were doing a similar question and you got n is a half, or n is 0.2, or n is negative 1, they're all examples of when we're saying, nah, it's not a term in the sequence because you can't have a position of negative 1 or a half. You can't have the negative 1th term. It doesn't make sense. Is everything making sense? Is everything okay? Yep, you can have first term, a second term, a third term, but you can't have anything else, like other things. Okay, let's move on. We're doing a lot of examples in this because there's a lot of different type of questions, but just let me know if everything's okay. Question 2. Find k given that 4k plus 1, k, and negative 3 are consecutive terms in an arithmetic sequence. So in other words, 4k plus 1 is one term. K is the next term. Negative 3 is the next term. If they are in an arithmetic sequence, what do we know would be true? Have a think. I'll just give you a second to think about it. We know it's an arithmetic sequence. It would have a common difference. Do we all agree? Yeah. It would have a common difference. And the common difference would be any term, name K. So D would equal, and you don't really have to write the D, K minus its previous term, which is 4K plus 1. And that would equal negative 3 minus its previous term, which is K. Does it make sense that that would equal that? They would equal each other. So girls, I don't mind if you don't write D, by the way. I just want to, I'm happy with even that. The point is that you understand there would be a common difference and it would equal each other. Now what can we do? Solve it. Let's solve it for K. You go ahead, I'll go ahead. Find the general term for an arithmetic sequence with U2 equals 10, U7 equals 34. What are they talking about? General term. UN, exactly. I want UN. I want the formula. But I would have liked it to give me U1 and D, wouldn't I? To find UN. That would have been nice, but they didn't. So the trick is to use these two facts. I want to find U1 and D, don't we? Let's write that down. We need to find U1 and D. So look at this. What would U2 be? U2, using the formula, I'll write it out over here. Remember, UN equals U1 plus N minus 1 D. Everyone okay with that? It's a bit small. So U2 would be U1 plus, what's N in this case? 2. 2 minus 1 times D. What does that simplify to? That becomes U1 plus just D. And what is U2? Oh, it's 10. Is everyone okay with that equation that I've found? Yeah. Everyone okay? Let's use the other fact, U7. What would that be? Is everything okay? Using the similar same sort of thing here. U1 plus in brackets 7 minus 1 in brackets. Everyone okay with that? Cool. And what does that become? 34. Oops. Oh, yeah, sorry. U7 is 34. Beautiful. Equals? U1 plus 6. Is everyone okay? Is everyone okay? Beautiful. What do we got here? Simultaneous equations. Does that make sense? Beautiful. I think the elimination method is easiest, but if you prefer substitution and that's what you do, that's fine. How could I eliminate one of those ones, U1 or D? U1 by what? Minusing? Subtracting? Yes. Girls, take a moment. You can do 1 minus 2, but I'm doing 2 minus 1 because 2 has bigger numbers. So let's do each one. What's 34 minus 10? 24. Equals, oh, look at this. Sorry. Let me go down. U1 minus U1, gone. Yes, good. 6D minus D. 5D. Ooh, it's an ugly one. Anyway. Everyone okay? And how do I finish off to find D? Divide by 5. (24 on 5), or actually, no, let's do it as a decimal. It's a little bit nicer. What would that be? 4.8. 4 on 5 is 8 on 10. Okay, so now that I've got D, how can I find U1? Sub it into one of the equations. What's the easier equation? 1, because U1 plus D equals 4.8. So I might write sub into 1. 10 equals U1 plus 4.8 minus 4.8 from both sides. U1 I think is 5.2. Beautiful. And I'm still not finished, but well, one thing at a time. I'll just stop and let everyone keep. What do I still need to do? The general term, or the UN. So let's go. UN, let's write the rule again. UN is U1 plus N minus 1D. So what does that become? 5.2 plus, yep, times, yep, which equals, it becomes 4.8N. Now, 5.2 minus 4.8 I think is 0.4. So that's my general rule, and I'm finally done. So we've got basically U2 here, which is 10, and U7 over here, which is 34. How many terms are in between them, or what terms are in between them? U3, U4, U5, and U6. Whoops, got a bit small. Okay, so to get from there to there, I would add a D, right? To get from there to there, I'd add another D, add another D, add another D, add another D. So what that means is 5 Ds should equal the difference between 34 and 10. Would that make sense? So 5D would equal 34 minus 10. Or in other words, 5D is 24, divide by 5, divide by 5. D is 4.8 or 24 on 5, which is right. So this is another way. And then, what's another way you could find U1 that's not doing this idea? From U2, exactly. But wait a minute, I've got U2 is 10, so U1 is 4.8 less than that backwards. So I could show that in my diagram by saying if U1's here, to get backwards I would minus D. Does that make sense? So U1 is 10 minus 4.8, which equals our 5.2, and that's right. And then UN blah, blah, blah. That's another way to do it if you don't like the simultaneous equations method. The only issue that I can see is possibly getting the number of D's wrong. Or, it's easy, it's 7 minus 2. Or if, we were lucky with, because it was U2 and I could just go back 1. But if the first one was like U10 and the second one was U36, that might be harder, but it's not really harder. So this is a valid method. Whatever makes sense to you, girls. Insert 3 numbers between 4 and 13 so that all 5 numbers are in an arithmetic sequence. This actually follows on from that, what we just talked about. So, girls, I've got 4 here. I'm going to spread it out, and 13 here. I want 1, 2, 3. That makes it easier. Okay, thoughts? To get from there to there, we add D. To get from there to there, we add D. It's like in the gaps. Do you know what I mean? So that's why, girls, 4D is going to equal the difference between 13 and 4. Does that make sense? So whether you visualize it, whether you literally draw that, up to you in like other questions. So 4 lots of D, you might just visualize it, is 13 minus 4. So 4 lots of D is 9. Oh, I made an awful one again. Divide by 4, D is 2.25. So D is 2.25. But I still haven't even answered the question. Add them so that we can find our actual 3 numbers that sit in there. So take a moment, girls. What is this first number? Good, because you're adding 2.25 to 4. What is this number? Second one. 8.5. And what is the last one? 10 point. Good. And you might just check with yourself, does it the next one add to 13? Oh, good. Yes, I did it right. If it doesn't, there's a problem. Is it making some sense? So I think that diagram really helped and that method really helped in that case.